Hi, welcome to the channel. In our today's project, let's learn how to make an AI face recognition using esp32 cam. So let's see the different components that we will be using here for our project. The first thing is the esp32 cam. In order to capture the faces, and then a baseboard for programming the esp32 cam that uses a micro USB cable in order to program it using the computer, and a PC or a laptop in which the Arduino IDE installed in it that we will be using for programming this esp32 cam, and then a simple smartphone in order to view the output, and some images. So you can use a colored image or a black and white image, whatever you have. So here the project is like we will be using these images so that when I put this image on this little stand here, this esp32 cam will scan for the image and it will convert the image into the corresponding names, and the names will be visible on this mobile phone. Right, so how does the esp32 show the names on the display is that this esp32 cam does two functions here. One is capturing the faces, and also it acts as a web server so that we use the browser from any mobile phone using Wi-Fi network, so that using the IP address, so here my IP address is 192.168.1.11 of this esp32 cam web server, so that we will be able to see the names. Right, so let's see the working now. Let me start with Cristiano Ronaldo. Let me place the image here. So immediately it showed the name Cristiano Ronaldo. Let me see for the next person. Here I place Luka Modric, and immediately it shows Luka Modric. Next we will go with Neymar. Shows Neymar, and finally Messi. Right. Let me pick a random one now. Let me go with the Luka Modric. Yes, it works fine. So let's see how to achieve this project step by step. So for this project, we will be using an online tool called Edge Impulse. So using a browser, you need to type this studio.edgeimpulse.com. In that, you can use the sign up option in order to create an account using your email address. So after that, you'll be getting this kind of page wherein you can start creating the project. So I think you can create 4 projects at a time in this Edge Impulse tool. So Edge Impulse tool provides a way to create small machine learning applications for microcontrollers like esp32 cam. So that is why we have chosen Edge Impulse. So now let's start creating a new project. So here you have the option called Create New Project. So once you make a new project, it will take you to a different page. So let me click on this, create a new project. So here you need to type in the name of the project and then click on this, create new project. So once you do that, it will take you to a page where let me open an already created project. So this is how the project page will look. So first you need to start with the option called data acquisition. So before that, you need to select for which microcontroller are you programming this project. So here you don't have esp32 CAM. Instead of that, you have the option called esp32 I. So you can select from this target device as expressive ESP I, ESP32 240 megahertz. And then click Save. Right. After that, click on this option, Data Acquisition. So here is the place where we will be collecting the images. So the reason why we need to collect the images is that the ESP32 CAM uses a sample images that you have collected in order to identify whether the image that you are showing in front of the camera matches that corresponding images that you have saved in it. So let's start collecting the images. So now using the sample images, we will be training the computer. Right, so now let me click connect a device. Yes, so here it gives you three options. One is scan QR code to connect your phone, connect your computer, connect your device, or development port. So we will use the first option because this first option it will be easy for us to collect the images. Right, so let me close it and show you the images that I have collected already. So this is how the collected images will look. Right, so I have collected all these images using mobile phone camera. So in order to collect the images from the mobile camera, you need to click this connect a device and then scan this QR code. So let's start doing it. So now let's start collecting the images. So I take the mobile camera and I scan this QR code, and this will take me to the browser page of Edge Impulse, where it will be asking me to select any options. So here I select collecting images. Now you need to click give access to the camera, and that's it. You can place it on the location where you will be collecting the images, and on the computer you need to click get started. Right, so here this is the location behind the mobile camera on which you will be placing the images that you want to scan for face recognition. So here, once I place any image, I need to click on this capture button over here. So here we have the capture button. So once I do the capture button, immediately I will get the captured image displayed on the screen. So here I can select this image to see the captured image, and also see that the image is properly aligned in the middle of the capturing image, so that your output will not cause any problem. So likewise, you keep the images a few distance apart, like few centimeter apart at each position, and you capture the images. Likewise, for every image, you can take a 20 samples. So I am having 4 images over here. So I've taken 20 samples for each, so that the total number of 80 samples are used for this project. So now we have collected the image samples. So for each football player image, I have collected 20 samples, so that a total number of 80. So I have added 2 more samples additionally in order to show how we process the image. So now I click on this newly captured image, which shows us the player named Luka Modric. So now the next step is to make a label for it. So in order for the computer to identify and map the corresponding face to the person named Luka Modric. So I just make a box like this by click and drag using the computer mouse. And here I can name the name of this person. So here I have typed Luka Modric, and then you need to click set label. So once we do that, this hyphen will convert into Luka Modric, the corresponding label name. Similarly, you need to do it for all the images. So let me delete these, as I've already done it earlier. All right, so this is how it's done for the player Messi. So for each different names, this label bounding box will be made of different colors. For Luka Modric, it will be of same color, whereas for Cristiano Ronaldo, this label will be of different color, blue, and for Neymar will be of different color. So this is a computer generated colors for the label bounding box. So now we have made labels for all the 80 images. So you can see the training number of images is 80. So next is we need to click this create impulse. Here, when you're creating a new project, you won't get these white box and blue box at this point. You need to select image from this option and then object detection from this option and click save impulse. Next, you need to click the image option at the left, and here you need to select grayscale. So selecting the grayscale option will make the microcontroller to process the scanned images in a faster rate. So I select grayscale here and save parameters. After that, you need to click generate futures. So here the computer will take some time and show you the result of how the computer differentiates between each of the images using AI. Yes, here is the map that is being generated, where we have 20 dots for each samples in the color of labels being displayed at each points. And I make it smaller. You can see that this Neymar is with the red color dots, and Messi with green color dots and orange color dots for Neymar, and Luka Modric, and then blue is for Cristiano Ronaldo. So you can see that these dots are being split and it's not being overlapped. So you just need to generate these features in such a way that these points are not overlapping for getting a proper result. Right. So now let's move on to the object detection. when we click the object detection, you will get an option called save and train. So let's click the save and train here. Okay, so now we got a message called job completed, and this is the metrics. This is for a reference like how far the computer will detect the image in percentage scale. So here for the person Neymar Messi, sorry, for Messi, Luka Modric, Cristiano Ronaldo, the percentage of recognition is 100%, whereas for Neymar it lacks 25%. So that's not a problem. But see that all the scores are above 75% for each. So if you get 100% score for all, so you will get a perfect result. And also see that the F1 score is more than 90% for a good accuracy for scanning the images. So next, let's move on down to the deployment. So this is the place where we will be converting this project into the ESP32 CAM program. So to do that, here in this deployment target, we need to select Arduino library. And here in the reference engine, you need to select TensorFlow Lite. After that, you can click this build option. So soon after we do that, our Arduino IDE file will be downloaded, and you can view that in the downloads. So now we have successfully created a zip file from the Edge Impulse that can be used directly to our Arduino IDE to make a project for the ESP32 CAM. So that's visible in the downloads. So when we place the cursor over there, it gives the file name with the .zip file extension. So now let's get into the Arduino IDE. So before installing the zip file, we need to make some arrangements for the ESP32 CAM so that the view of the ESP32 CAM should be same like as we did using the mobile phone. In order to achieve that, you need to open the project from the examples. That is examples, file examples, then ESP32. You need to look for ESP32 and camera web server. When you click on this, it will open a project that has been installed during the installation of ESP32 libraries. So the project will look like this. Let me open it. So the project will look like this, inside which you can define your Wi-Fi password and Wi-Fi username. So the reason why we use is that this project will make a web server so that from the web server you can stream the video and you can set the position of the webcam according to the way it can scan the images of the football players as we did in the mobile phone. So you can adjust the height and the position as well using this. So using the IP address, you will be able to access the web page so that from that you can adjust the position. The one change you need to do here is that you need to you need to uncomment this. You need to comment this, and then you need to remove the command for AI Thinker over here. Camera model AI Thinker. So only after this you need to upload it. Otherwise, it will give you an error. So once we have set the position and you're confident that we can go ahead. So you can now install the libraries that we have got from the Edge Impulse. So I will go to the sketch again. So from here, I will look for the examples. Sorry, first we need to install the library, that is the zip file. For that, you need to click the sketch, include library, and you need to click add zip library. So it will take you to the zip files that you want to install. So I need to locate the downloads from which we have the recently downloaded file, that is football players face recognition .zip file. So once you click that and click open, it will take 1 or 2 minutes and it will give you a message that processing your zip file. After that, we can start making use of it in the project. So now let's say that our zip file got installed. In order to view the project from that zip file, you can just click the file, examples, and under the menu called examples from custom libraries, under which you will find the football players face recognition interfacing, and which leads to esp32, and then you need to click the esp32 camera. So after you do that, it will take you to this project file. This is how the project file from the Edge Impulse will look like. So here there are some predefinitions for the camera. When you come down here, this is the place where the returned object of the face recognition will be fetched. So here bb.label, bb.value represents the position and the name of the image that is being scanned. And also, if there is no object in front of the camera, it will return this predict loop here over here that says predictions DSP %ms. If there is an object detected, then it will get into this loop where it says the edge impulse EI for edge impulse classifier object detection equal to 1. So there is an object being detected. So display this values of the image. So using this, we will fetch the required data that we want to display it on the web page, and using a web server code for this ESP32 cam, we will be able to display it on the mobile phone. So now let's see how to fetch the text. So we use a different project for that to fetch the text. So here is the web server project for getting the text and displaying it on the web page using Ajax. That is, Ajax is used for displaying the text without refreshing the page. So what we will do is we will combine this code and the Edge Impulse generated code together. So let me directly get into that code. So this is the combined code of both. So here it starts with, so as I named it as ESP32 cam football face recognition after editing. So these are the code that I included from the dynamic text displaying web server code. And coming down over here, and you need to do a change is that for this code, you need to again uncomment, you need to comment this ESP32i, and you need to disable the comment for this camera model AI thinker. And when you scroll down, yeah, this is the place where there are two loops, whether the object is being detected or not detected. So if the object is not detected, this loop will be triggered. And if the object is detected, this loop will be triggered, which will be returning bb.label, it means that bb is equal to result.bounding boxes. So it will get the edge impulse will automatically get the bounding boxes as the objects, and it will return the object name and the percentage accuracy, and then x value position and y value position, and then its width and height. And from this, I'm fetching this bb.label, and I'm returning that in the dynamic string, where previously we were using the dynamic string as the counter value, but here I'm using this name as the value for dynamic string, which will be displayed on the web page over the top. When you scroll, that the player name dot inner HTML is equal to data, which will be called again and again for every 2 seconds. The function name is get sensor data. So you can name it as a different function name. When you scroll down, you have this, whenever this get string is called from the web page, then it will return the handle string. So which will return the value dynamic string. So that's it. I hope you understood the project, and yeah, it takes some patience as well as time for achieving the final output. No worries. So if you have any challenges while trying this project, you can comment in the comment section, so we will figure out over there. Thank you so much, and I will attach all the 3 files, that is the dynamic text web page displaying project, and then the edge impulse generated code, and also the combined code. So I'll be attaching the 3 files and the link on the description box. You can refer from there, and let's see the output here. Okay, in order to view the output, let me clear the serial monitor and connect the esp32 cam to the computer. And also let me scroll to the place where the code will be printed out. This is the code. So I have made a change that serial.println, the label is the label name. So for each player, the name will be the label. And as I said earlier, if there is no object, this loop will be triggered. The predictions will be triggered, else this loop will be triggered. So now I have connected the esp32 cam. So now it's connecting to my Wi-Fi network, and then it shows predictions DSP 7 milliseconds classification anomaly. So it shows this. Oh. So it shows this message over there. So let's say that I'm placing a player's image in front of the camera. So immediately it shows the label is Luca Modric. So that message is from over here. The label is bb.label Luca Modric. And also it gives you the X value and Y value of it, the positions and the width and height of it, and also the accuracy. It's 0.9 accuracy. Thank you so much for watching. Let's meet again with another project. Thank you.